Welcome. The next ideology that we are going to see is geometric distribution. Recalling the previous distributions, in binomial, we repeated the Bernoulli trial for certain number of times and observed the number of successes that we obtained in that repetition of the Bernoulli trials. And in Poisson distribution, we repeated the Bernoulli trial for infinite number of times. Okay. Whereas in geometric distribution, we are going to repeat the Bernoulli trial until we get a success. Which means once we have obtained the success, we are going to stop the repetition of the trials. Okay. So when we do it until we get a success, once we get a success we will stop it. Okay, here the PDF is of this form. How do we get it? Okay, let us see. Suppose we expect that we are getting it in the first trial. Remember, here x is running from 1 2 3 onwards. Okay, so it is that if we get the success in the first trial, it means it is p. The probability is p. Suppose we get the success in the second attempt. In the first attempt, what we have obtained is a failure, and in the second, we get the success. Suppose we get the success in the third one. So for the previous two times, we get the failure. Okay, so this is how it is going on. So supposing we get the success in the xth trial, which means for the first x minus 1 attempts we got the failure, and in the xth trial only we got the success. So this is how the PDF comes. Okay, coming to the problem, it is said that 10 percentage of the bulbs produced by a company are defective. Okay, so it is understood that the probability is 0.1. If you are examining these bulbs one by one from a large production lot, what is the probability that you are getting the first defective bulb on the 12th one examined? Which means we are examining 12 units and we are getting the failure, the first failure in the 12th, which means in the first 11 trials we got failure only. So it is simply q, that is 0.9 to the power 11 multiplied with 0.1. If you just calculate it, you will get the probability. Okay, now here in this problem it is said that a boy is throwing stones at a target. Okay, now what is the probability that the fourth attempt is the first hit? Okay, simply is throwing stones at particular target, and the probability of hitting the target is something 0.3. Okay, in the fourth attempt he obtained the success, which means in the first three attempts he obtained failure only. So you just have to do q is 0.7, that is 1 minus 0.3. So that is 4 minus 1, that is 3, and that is 0.3. When you multiply it, you get some value. This is the probability of obtaining the success in first attempt. Okay, now we have something interesting with this distribution. Okay, what is probability of x greater than n? But before that, supposing we wish to find the mean and variance of this one, how do we do it? Generally we start with finding the moment generating function. Okay, here it is expectation of e to the power tx. Here your summation is running from 1 to infinity e to the power tx, and this is p x power minus, sorry, q to the power x minus 1 product with p. Okay, and here this p is independent of x, so we take it outside, and this is, this one we write it as e to the power t whole power x. So 1 e to the power t, let me take it outside so that it becomes summation x tends from 1 to infinity q e to the power t whole power x minus 1. Right? So, and now what is it? You can see that it is 1 plus q e to the power t plus q e to the power t whole square, plus it goes on. Now that it is a geometric series, so it is p e to the power t 1 minus q e to the power t. This is our m of t, isn't it? Okay. So what is m prime of t? Okay, I am skipping the entire derivation here for the time being. Now that you got the idea of performing the differentiation, so if you just do it, you would get this quantity as your m prime of t, and this is at from this your mu, that is expectation of x, that is the derivative at 0 is p divided by 1 minus q whole square, that is p divided by p square, which is 1 upon p. Okay, and if you find the second derivative, you would get some lengthy expression, that is 1 minus q e to the power t whole square multiplied with p e to the power t minus p e to the power t multiplied with 2 times of 1 minus q e to the power t multiplied with minus q e to the power t, this entire stuff divided by 1 minus q e to the power t to the power 4. So from this your mth derivative, sorry, second derivative of m at 0 is p cube plus 2p square q upon p to the power 4. Therefore, your variance of x is this quantity minus 1 upon p square. Okay. Upon simplification, what you get is p square p plus 2q minus 1 divided by p to the power 4. So this one is okay. I don't think it may not be visible over here since videos here. If you just simplify it, p plus q is 1, so 1 minus 1 is 0, so you are left with q alone. So p square, and here things gets cancelled, it is q upon p square. Your variance is q upon p square. Okay, moving further, here we are asked to find out probability of x greater than n, which means what? Summation x runs from n plus 1 to infinity q to the power x minus 1 product with p, isn't it? Okay, what? Okay, this p is independent of this thing, so when we substitute, it is q to the power n plus q to the power n plus 1, and it goes on. So here we just take this q to the power n outside, so it is 1 plus q square plus etc. So it is p q to the power n. It is again a geometric series with common ratio q, and that q is smaller than 1 since it is a probability. It is 1 upon 1 minus q. What is 1 minus q? It is simply p, right? P q to the power n multiplied with 1 minus, 1 upon p. So this p and p gets cancelled. You have q to the power n. So probability of x greater than n is q to the power n. Okay. Now we have something called lack of memory property, right? So this is what we need to prove. Okay, and here probability of a given b is probability of a intersection b upon probability of b. So here from this, here things are independent, so it is probability of x greater than m plus n divided by probability of x greater than m. Since these two are independent, we get like this. Okay, so x greater than m plus n means what? Q to the power m plus n divided by q to the power m. So it just cancelled and we get q to the power n, which is probability of x greater than n. So what do we mean by lack of memory property? This m is some quantity which is a finite quantity. Okay, after this we are going, given that it has happened, what is happening here? This is what we are going to see. But it just, here this calculation tells us that it just doesn't consider what has happened till m. Okay, if we are starting from the scratch and see what is happening till m, that is the same if we consider this as well. So this, if you are getting something of this expression, okay, This one is known as lack of memory property. Okay, and here you see the probability that a man hits the target is 1 upon 5. How many times must he fire so that the probability of hitting the target at least once is more than 90 percentage? Okay, at least once. Okay, it means suppose that he has obtained failure till nth trial, so the probability is q per n. Okay, but he has done at least one, so 1 minus this quantity should be greater than 0.9. Okay, we just perform some calculation and see what is happening, and we get some value of n. Okay, I think I'm not very sure this calculation is right or not. Okay, so from this what you can do is that 1 minus zero point 0.9 is greater than 4 upon 5 to the power n. Okay, so it means 4 upon 5 to the power n is smaller than zero point 0.1. You just take log, so it becomes log of this is zero point 0.8, isn't it? Less than log of zero point 0.1. So your n has to be smaller than. You just calculate and find out the value of n. I don't know whether this value is right, but this is the idea. Okay, that's it. Thank you.